This video is a continuation of the looping conditions and comparisons notebook, and we're going to discuss conditional statements operating on sequences. We've already seen that expressions which evaluate to non-zero are considered as true, and those that evaluate to zero are false. Sequences can be used similarly in that any sequence with non-zero length is considered to be true, and all empty sequences are considered to be false. So if we were to write if, and then give a non-empty list as a condition, and say maybe print true, else print false, we see that true is printed in the output. Likewise, if we tried the same thing but used an empty list, we see that now the output is false. And this works this way for all sequences. So if your sequence has no values in it, it's empty, it'll be considered false. Otherwise, it'll be considered true. So we can also use comparison operators with sequences, as long as the operands are both of the same sequence type, meaning that I can compare two lists of integers, but not one list and one string, for instance. Now, comparisons between sequences use lexical ordering or dictionary ordering, and the elements in sequences are compared pairwise in order. If sequences contain subsequences, then the comparison is handled recursively. So if we were to ask if the list containing 1, 2, and 3 is less than a list containing 1, 2, and 4, we would get true because the comparison checks the elements pairwise in order. It sees that the first two entries are both equal and continues on until it gets to 3 and 4, in which case 3 is less than 4, so the first sequence is less than the second sequence. If there were more elements in both of these sequences, the comparison would actually not continue comparing them. Once it finds a pair of elements that shows one sequence is less than the other, it stops and returns its result. So if we were to add an element, say, to the first list, we would still get true, and there's no issue if the sequences are of different length, as comparisons are made until at least one of the sequences is exhausted. Now, if all the elements in both sequences are equal, then the sequences are considered to be equal. So if I write 1, 2 less than 1, 2, we see that the result is false, because both lists are the same. However, if a sequence is an initial subsequence of the other, then the shorter of the two is considered to be lesser. So if I add -1 here to the second list, you can see that the first list is now considered to be the lesser of the two. So we get true here in this case. Now I said that comparisons must be made between sequences of the same type. But if the elements are comparable or convertible, like floats and ints, then this will still work. Also, I mentioned that if the elements were also sequences, then the comparisons are handled recursively. So if we wanted to compare a list of strings, the strings would be handled in order in the lists, and the characters of each element would also be compared in order. So in this example, the string AA is less than the string ABC, so the expression evaluates to true. Similarly, if we were to use these lists as sublists in another list, the comparison is still handled recursively, and you'll see that AA here is still less than ABC, and so this comparison would still return true. And as a last example here, we can also use chaining with sequences. So we can write ABC is less than C, is less than Pascal, and less than Python. And because of the lexical ordering used in these comparisons, this expression evaluates to true. And of course, this is equivalent to ABC is less than C, and C is less than Pascal, and Pascal is less than Python. So the chaining and comparison operators gives us a little bit of a shortcut and makes things a bit easier to read.